What are people's opinions on SQL so far? I've heard some people, they like it. Does anybody not like it? No opinion?
I'm kind of, I mean, I like it, and it seems pretty intuitive how it works. I'm curious to see how we're going to blend it with, like, it's one thing to go get the data, actually like analyze it and manipulate it and stuff. And so I'm curious to see how we're going to mix Python or some other language with the actual data collection via SQL.
Cool. Yeah. So tomorrow you're going to kind of see, we're going to incorporate Python and SQL. So we're going to combine, you're going to get like a CSV file, open up the CSV file, grab the data from the CSV file, manipulate that data, and insert it into a database. So you're going to kind of see how that works tomorrow. But yeah, all right. So with that, we're going to review SQL basics. I'm in Mike Platoon, SQL basics. I need to fork it over to my personal GitHub. So fork over to Tom Preet. It's going to scan it over. While it's doing that, I'm going to open up VS Code right here. So right now it's at Tom Preet's SQL basics. I'm going to clone it by copying this URL. Come down here, open up the challenges. Right here are all my challenges. I'm going to open that up, zoom in. Oh, it's big. So I'm going to clear the screen, and now git clone the Tom Preet SQL basics. There we go. I can list everything again. I can see the SQL basics is right there. I can cd into SQL basics and open that up in the current VS Code window. All right, so I'm going to open up here, schema. I got some seed data in the README. So let's kind of come over here. So for the most part, you'll interact with your database by executing SQL statements. So it's a totally different language than Python, JavaScript. So in this challenge, we're going to be creating a database, writing SQL to create a schema or tables of the database. We're going to inspect our schema. We're going to insert new records from a provided set of seed data. So here's our seed data that's already given to us. And then verify seed data records were inserted with the select SQL statement. So the first thing we need to do is create a database. How do I create a database? Jarrell, how do I create a database from the command line, from the terminal?
So you can do create DB, and then you give it whatever name you want to.
All right. So again, I'm in my terminal. I can do create DB and then the name of this database that I want. So for this one, we want to create a database named school. So I can do school. It says, uh-oh, create DB database creation failed, arrow database school already exists. So I want to delete this and start fresh with a new school database. How do I delete a database? Giovanni, how do I delete a database?
I think you gotta drop the data. Oh, that's the table, right? But for the database,
you got it right.
Do the same thing?
Yep, it's drop what?
The name of the database is school.
So school, is that right? Drop, not command, not found.
I haven't like deleted the database yet.
Does somebody know the command for it?
I think it's just delete.
Drop database, then the name.
Yeah. Drop database?
Drop DB.
Drop DB. So just like we did create DB to create a database, to drop a database, we do drop DB school. Click that. Nothing showed up in the terminal, which is usually a good sign. So now I can go ahead and create a database. So I can go up to that previous command, which is create DB school. And again, nothing happens. So that's usually a good sign. Now I want to see if this database exists. So how do I connect to the Postgres server or the school database in the terminal?
PSQL school.
PSQL school, what the name of it. So you can see I'm in the school database, and in here I can literally just type in a bunch of different SQL commands. I can do D, so / or \D will show all the tables that are already created. So it did not find any relations, so I haven't created any tables. So I can do \Q to quit, and now I'm back to my terminal. Let's look at right here. So we kind of just went through this. That's expected though we don't have any tables. So now we can actually create or design our database schema. All right, so before we can insert any data, we're going to need to define our schema. One important we need to cover before we create a table is primary keys, blah, blah, blah. While designing all of our tables, incrementing integer as a primary key, sometimes you might be tempted to use another column as a primary key, like a social security number, but it's not always a better choice to have an independent internal primary key. Or it's always better to have a choice, or it's always a better choice to have a primary key. So let's open up our actual schema table. Right here, that's what that looks like. So there's a bunch of different types of columns types that we can have, like varchar, date, integer, there's Boolean values, there's a bunch, and you can just like postgres type, column type, or field types. Postgres. So here we go. Here are a bunch of different types. And you can kind of see them all. All right, I just want to go through this. Add the missing create table statement to the included schema. You can run this file. All right. So it looks like that is it. So now, clear. Now I've got this schema right now. How do I insert it into the school database?
I think you gotta do PSQL, then the name of your database. Then you go with less than the sign.
Oh, less than like that?
Uh-huh.
Okay.
The name of the file.
And then
underscore schema.sql.
Okay, yeah, exactly. So I list the name of the database, and I'm this little arrow pointing into the database, the less than side, and then followed by the name of the file. So I'm saying, hey, take this create schema file and execute it within the school database, and let's see what happens. So notice table students does not exist, skipping. Drop table, create table. The one thing I don't really like about SQL is that their errors they don't really tell you exactly what's going on or where the error occurs. So that's one hurdle to get over versus like Python or JavaScript errors. So right here, this notice table students does not exist, skipping. That means it's up here, it's saying drop table if exists students. And it's like, hey, this students table does not exist, and we're gonna skip it. And it still runs the drop table. And then it says create table students, and there we go. So
hey, Tom, can I ask maybe it's a philosophical question about these files? Is this a normal way to create tables using an external SQL file by just entering it in the terminal as you're creating? Or is this just kind of a thing we're doing just to learn all the commands and be able to recreate tables quickly? If that question makes sense.
So yes, you can technically do this, and it depends on how your application is set up. But yeah, you could, this is how you would more often than not create it's more often the most efficient way to create a table if you're just using SQL, like raw SQL, and if you're not using any ORM to write your SQL or create tables or anything like that. So yeah, this is pretty standard.
Okay, thank you.
But you'll see as we actually get into Django and other ORMs, you'll rarely be writing SQL files to create your tables and databases and all that stuff. You'll be using an ORM, object relational mapping. So I'm going to go into my school database right here. And now I want to inspect it by doing \D. And there we go. We have our school students table, and looks like the sequence. So it's got a student ID in it. Let's go here. So if we look up here, here's our create table is our command. Create a table in the students, then create a table named students, followed by parentheses, and then ID, first name, last name, birth date, address ID. These are all the column names. So like if you think of a spreadsheet, they're like the headers. And then the serial is primary key. This kind of just indicates that like, hey, every time you create a new table or insert a new element or new record, it's going to increase. Yeah, so it's automatically going to set to the next number in the sequence starting at 0. And they're always going to be unique. All right. So it's not always necessary to specify not null for primary keys. They're just not null by default. I've allowed address ID to be null at first. Okay. So it says here are the other tables that we're going to want to create: addresses, classes, and enrollments. So I'm just going to copy that down here. Addresses. All right. Classes and enrollments. Is that right? Okay. So let's start with addresses. Let's create some addresses. So we can do the create table, addresses. There we go. So what do we want? We want an ID. We want this to be the primary key. We want line 1. And what do we want line 1 to be? Postgres data types. I think I already kind of looked at that. I'm going to look at Postgres tutorial. It's a pretty good one. So we have Boolean characters. What should line 1 be?
Varchar.
Varchar. So we have varchar as a variable length character string with, you can store up to n characters. Postgres does not pad spaces. Okay. So we can do varchar. There we go. How long do we want a line of an address to be? That's
35 max.
35 max. There's got to be addresses longer than 35.
Well,
right?
I was Googling the other day for like max length addresses just to try and recreate the scenario, and I think that's what I came up with.
Okay. We'll do it.
What if it's not in?
What if it's not in America or the US? Is that what the question was?
Oh yeah, it could be long.
Yeah, it could be in like Austria or Germany or somewhere like Iceland or.
Yeah,
So
that
yeah,
was one of my assumptions, that it was American-based
Okay.
school.
Let's just do 255. All right, and then we have city, varchar. There are some pretty large cities names. Let's do 255 again. State. So I guess we can assume that, but let's do varchar What's the longest state name?
Rhode Island in America.
Okay, Rhode Island. Is it? What is it?
2, I think. It's 2 letters for the state.
Let's try 2. All right. So yeah, maybe it's an abbreviation. Let's just start with that now. Again, we can always modify it later.
Quick question.
Yep.
When you were referencing that PSQL cheat sheet, it says on varchar, it says does not pad spaces. What does that mean?
Does not pad space. I actually don't know what that means. So Postgres does not pad spaces when the stored string is shorter than the length of the column. I don't know what that means.
Does that mean like if you have like 40 characters and the length is 50, it won't add like 10 spaces maybe?
I Googled it and it says, and I don't know what this means, but it says padding is the space that's inside the element between the element and the border. Padding goes around all 4 sides of the content, and you can target and change the padding for each side, like a margin.
Yeah, I don't know. I actually don't know what that means. Do you know?
I'm assuming that it's saying that it doesn't it doesn't, add spaces so that text will appear like in the middle of the column. It'll just start at the left-hand side.
Okay. Yeah. I don't think it has anything to do with. Yeah, I've never encountered. I don't even know what that means. I've never ran into any issues. It might. Yeah.
I think in the CS50 class we took, it was talking about like exactly that example. I think it was Gio was saying where if it's 50 spaces and you only have 40 characters, it wouldn't take up that extra 10.
Yeah, that's what.
Varchar.
Yeah, that's what I was kind of thinking. So if like the minimum is 50 here and your value is only 40 spaces, it doesn't add spaces when storing it or something. Yeah. All right. So we have city, state, zip code. How do we want to store a zip code? Do you want it to be an integer or do you want it to be a string? Does anybody have a preference?
Well, some people use those extra extensions on their zip codes that have a dash, and so you got to make sure you're accounting for that.
Okay, so we're gonna do varchar, and well, we can actually limit it. We don't want this people to put in. Oh, we'll just do 10 for right now, and we can also take a look at our seed data and see what they put in there to glimpse at it. But all right, we have create add table address. All right, so it should be addresses. Are we done with that one?
I have a question. Why is like certain words like state showing up as blue versus others not?
I don't know. Obviously, something in SQL, something within VS Code SQL live, whatever extension is highlighting state. If I do,
Name does it also.
What does do it?
Name, I think. Yeah.
Yeah, I think I ran into that with user on the when we were making the Grubhub example.
Yeah, I don't know specifically why, but it doesn't affect anything. It's just, it might be a commonly used value. I don't know why. Birthday, first name. Yeah, not sure. But it doesn't change. It doesn't like mess anything up or anything.
Tom, you may need a semicolon after that addresses table.
Right here?
Yeah.
All right.
And there are commas in between.
And I need commas. Do I need a comma at the very end too? Or is it kind of like an object? Okay, cool. So next one, create table. What's the next one? Classes. Classes. We can do ID, serial, primary key, comma. We can do name. What do we want to name? Obviously varchar. Let's do 255 again. Let's do not null. And then we can do credits. And we can make that an integer right now. And then last but not least, and don't forget the semicolon. So we can do create table, enrollments, ID, serial, primary, key, is it student ID? So, so this is going to be reference the student ID in the students table. Can somebody tell me how do I make sure these tables are connected, and how do I make these ensure that this ID represents a student's ID? Let's look it up. How to create foreign key on Postgres. Postgres tutorial. Let's check that out. Foreign key constraint. So, okay. Set null. Generated always as identity. Constraint, foreign key. I want to actually see like an example. Example. Can I look at that? Constraint. Do I want it to be foreign key? Create foreign key, create in Postgres example. I don't know. No, that's not what I want. Joins between table. Postgres oh geez, SQL reference table, reference foreign key. Is that what I was already kind of looking at? Is it foreign key? So I got customers, I have contacts. So this would be the primary key, customer ID. This is weird.
When we were doing it yesterday, we were just using the references keyword. So you could put like the data type and then references and then the name of whatever the table was that you're trying to reference the primary key from.
Okay, let's take a look. So something like references cities. I just want to see if there's like an actual example I can find.
I think I found an example, Tom. I messaged to you on Slack.
The Zoom chat.
It's in the Zoom chat?
Or in the Zoom chat, but.
Okay, an example. Yeah, I just want to see if there was like, I can Google one, because I know there was one, or I thought there was one.
I put a link in the Zoom chat also.
There's a link to a Google, a link to a Google. Oh, geez. let's see what that looks like. So yeah, I mean, I'm just trying to like, all right, where's the chat? Chat's not opening. Come on, chat. There we go. So like, oh yeah, this is kind of what I was looking at. So varchar references. Cool. Let's take a look at that. So we're going to do student ID. It's going to be an integer. Let's do it not null initially. And then we do a keyword of references. And then students, right? Does that look right? Then we can do the same thing, but with class ID. And then classes. And at the very end, we can do grade. And the grade is going to be a varchar. And with a grade, how long do we want a grade to be? Because you're going to have A, B, C, so 1, but you can have A plus, B plus, C minus. So let's make it a length of 2. All right. Does that look right? So we have students, addresses, classes, enrollments. There we go.
Shouldn't the students and the class ID have like the ID in parentheses after students and classes?
Like right here?
Yeah.
By default, it automatically references the ID in students, in the students table. So you can do ID, but if you wanted to do, oh, sorry, go ahead.
By default, it knows where the primary key is in that table.
Yeah.
And then another question for the students table up there for the address ID. Does that also need the same kind of references thing? And why would we put it? Why would we put the address ID in students versus put the student ID in addresses when addresses is the child of students, I guess?
Because if you has anybody had siblings go to the same high school in the same grade, or like not in the same grade, but attend high school at the same time? So technically, a school can have students that live at the same address.
Gotcha.
Yeah. So why wouldn't we do references? Addresses. We can try it out. I think what might happen, it might throw an error, but we'll check it out. We'll check it out. So now we can load our schema with the following command: create schema. So I'm gonna down here in the terminal, I'm gonna clear it. So we've created our schema. Now we can run PSQL school, create schema. Let's run that. All right, so drop table, create table, relation students does not exist. All right, addresses does not exist. So, so I dropped the table students. I created the table. Let's just actually just check it out. School, so I'm in my school database. I can see them all, and I only have addresses and classes created. Interesting. So what happened was, what I thought was going to happen. So I dropped the table students. I tried to create the table. It says, hey, reference the addresses table in this field. But add the addresses table does not exist yet.
Wouldn't you put a foreign key in addresses to students? So you would put student ID in the addresses table.
If there's multiple students that live at the same address, then this wouldn't. If we had like the student ID right here, that means only one address could be associated with one student. But in the case that multiple students live at the same address, that's why we wanted to do the address ID on for that individual student.
Okay.
So when you're creating the tables, would just addresses have to be above students since it references it?
Yep. So that also is important, is to, when you're running the file, make sure you have the tables being created in the order so it doesn't throw errors. So if I deleted this and ran this, it should be fine. But let's, right here, it says table students does not exist, skipping, drop table, create table. Oh, it says syntax error. See, this is where the errors like kind of suck. Error, syntax error at or near. Okay, that's here. Like where is that? Here or here? I don't know.
I think it's 16, line 16, the comma.
Right. Yeah. See, but how is that? Why does it say line 7? Like that? Like I don't. Why?
That's
So
kind of near 7, right? 16.
It's in the vicinity of it.
Oh, because it counts that first semicolon as like one command, so it starts the next command at line 10, and that 10 becomes 1, I think.
So yeah, 1, 2, 3, 4, 5, 6. So if it starts at 1 or line 10, 1, 2, 3, 4, 5, 6, 7. That makes sense. Let's try that again. Cannot drop table students because other objects depend on it. So this is where you start to get into like a loop, like, oh crap. So what happened? Cannot drop table students because other tables, like another object depends on it, which is, I believe, is the enrollments table. Okay. So constraint enrollment ID foreign key on table enrollments depends on students.
Hey, Tom?
Yep.
I think you could drop all of them.
Yeah, one way
At the
that
beginning.
the quick database design output did it was just put all of your references at the end as alter table statements instead of trying to put them in like as you're defining each table. So that way it creates all the tables and then after the fact alters the tables to reference all the foreign keys.
Okay. Well, that's one way you can do it. Definitely. Yeah. So you did the output file from that. So this enrollments. So I need to drop all the tables first. And then right here it says hint, use drop blank blank cascade to drop dependent objects too. So I'm going to do cascade. So what cascade does is it says, hey, if there's another table that depends on students, also drop that table or drop all the objects within that depend on it. So let's try to run this and see if it works. So drop cascade constraints, enrollments, table enrollments, drop table, drop table. Okay, that's fine. So it dropped all 4 tables and then it created all the tables. So we didn't get any errors. We just had some notices. But what if we did references, addresses right here? Just run this again just to see if it works. Error relation addresses does not exist. So that's where, hey, maybe we want to move addresses in front of students. Clear it, run it again. Now everything works. Does anybody have any questions?
I got a question on the relationship. So when you have a many-to-many relationship, like technically students to addresses is now a many-to-many relationship because many students could have many addresses. So, and many addresses can have, I guess, many students. So in that case, would you share foreign keys on each table?
So with this is a one-to-many. So one address can have many students. So a student can't have many addresses because when you create a student, you only have one address ID. So one student can only have one address, but one address can belong to many students. And when you have a many-to-many, that's where you'd create a join table, and we'll get into that after this. You'll essentially have another table that has foreign keys of both tables on it. But yeah.
About the cascade keyword, Tom. So cascade is basically saying like if a table is dependent on the other table, drop both of them.
Yeah.
Okay.
All right. So now we can test our schema. Let's go into that. So we can do PSQL school, test them all. So cool, we have all the addresses, students. Great. Now we can inspect each individual table to see the fields and the types of each field. So address, line, cool, not nullable. We can do that for pretty much all of them. So classes, students. There we go. Cool. I'm gonna quit. And now, so we kind of tested it. We inspected all our tables. Now we can actually insert all of our seed data in our table. So we have our seed data, and we'll kind of see if there's any issues with it. We can adjust our tables accordingly. So you can see them all. So we're inserting into addresses, ID, line 1, city, state, zip code, blah, blah, blah. Okay. So now we're going to run this PSQL school, insert the C data. All right, a bunch of stuff happened. It said insert or update. So what happened? There are a bunch of errors. Value too long for type character. All right, insert or update a table students, violation forward key constraint. All right, so we have a bunch of stuff that's going on, but right here, let's tackle this first error. Too long, variant type 2. So it looks like the state. So if we look at all the states that we're inputting into here, South Dakota, let's do like, 50 or whatever. So we can clear the bottom. And instead of seeding the data, let's create the schema again. So we dropped all the tables, we created all the tables, seed all the data. Do we get any errors? No, so that was the only thing it looks like that was we were running into. Does anybody have any questions about the seed data? So now let's actually just see if there's any data in the PSQL file or database. So in the school, we can select everything from, let's say, students. And there we go, got all the students. Oh. Students, addresses, got all addresses, classes, cool. And what else do we have? Enrollments. And there's all our enrollments. If you downloaded Postico at all to get like a GUI interface of what your, where'd it go? Let's see, is Postico working? All right. So if you downloaded Postico, here's a visual representation of all the databases on my local machine. So I have all these ones, and I can see I have school down here. And there's my school tables, addresses, classes, enrollments, and students. I can even inspect each table like so. Come back to school, see classes, enrollments, students. If I wanted to insert a student into a row, I can manually do that. Address ID is 4. And then, so I added a row. I can discard the changes. I can save the changes. I can even preview the raw SQL of what I'm actually doing. And then I can actually save the changes right there. And if I wanted to see all the students, I can see Tom Preet right there. But this is the best. Get used to typing in the actual SQL commands instead of using the post-it-co or a GUI. All right. So with that, I worked on the master branch. It's not good to do that. You can get checkout -b instructor solution, get add everything, get status modified. So I just modify the create schema. I can get commit and instructor, and get push origin instructor solution. Uh-oh, what happened? I spelled instructor. There we go. Does anybody have any questions about the basics? Nope. All right. With that, I'm going to make a pull request. Come up here, compare and pull. It's going to go over to Mike Platoon. It's requesting to pull Tom Preet's basics instructor solution branch into the Mike Platoon SQL basics master branch and create that pull request. And no merge conflicts. We're good to go.